Hi everyone, my name is Thomas Kim. Today is June 29th, 2019. This is my 40th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about placement new operator. If you click this link, you can read more about placement operator. Start Visual Studio Code. Click this button to display Explorer pane, CPP extension tutorial folder. Click this button, O40, placement, new, CPP, hit enter. Ctrl V, include, IO stream, include, new, context sphere, size T, buffer size. I will place 10, for example, int g buffer size. This is global buffer void test placement new operator. int main, int pointer ptr1 new. We are providing here in the parentheses the address of memory location. We will use gbuffer 0. Okay, then we can provide address like this. Then we define type, and here we will initialize 10. std cout ptr1 std and there. Start command prompt. In CPP extension tutorial folder, dir 040 star, hit enter. This is the file cl ehsc std C++17 040 placement new cpp fe aexe, hit enter. cls a. We have to call this function, copy, pasted it here. We build once again cls a. So this is placement operator. We can also do this. I will copy this once again. This is the same. This is the same as before. And I will allocate double dptr new gbuffer v+1. Because this is one, we already used the first buffer, we increase 1, double 3.14 std cout dptr std and hit enter. So it works properly. If we want to create another double dptr2 new dptr double 22.0 divided by 7.0. We copy this once again. dptr2, dptr2. We are using here pointer arithmetic. Hit enter. You can see the results are working properly. This concept is called placement new. It requires understanding about pointer arithmetic. I will give you a few more examples. Now we want to allocate long LPTR new. Now we have to use this pointer +1 long 7 ULL, so we can ignore it. std cout LPTR std and build once again A. Now it works perfectly. Please understand that this is base address. This is the same like this, 0. And when we allocate another object, we use previous buffer. We can use PTR1 here, like this. We have to use previous pointer. And when we allocate here another one, we use previous pointer. And when we allocate another one, we use previous pointer +1. This is very low-level programming. I highly discourage using low-level placement operator. However, we sometimes need to use low-level technology in C++ programming. I highly discourage using low-level programming technique. I will give you another example. Now we can use local stack. Void placement new using local stack buffer. Now I will copy this function, paste it here. At this point, context sphere size t, buffer size, for example 10. Not this is buffer size, I say buffer element count, int local buffer element count, int a new local buffer +0. This is the address, the location in local stack. int we initialize with value 0. std cout a std and we build once again A. So it's working properly. Instead of doing this, we can use reference and we place the reference operator here. Please note that this is the reference operator. A is now reference. so we don't need this. This is much cleaner, like this. A. Okay. Now we are doing the same thing using double D new. We have to use this address, the address of A, like this. A. And the next one, double 22.0 divided by 7.0. STD. Here we have to use the reference operator. STD cout D equals D. STD, and we build once again. We run it. Now it's working properly. If we want to allocate another integer, now this time with short s new, we use previous address d plus 1 short. I will use like this. It's not working. I will just place like this. Then the reference operator std cout s equals s, and std, and now we build once again like this. Now let's think about how to delete. Include type trace, include memory. I will create here template, type name, type, void placement, delete, type. This is pointer and reference, ptr. If context pair std is class, type, and std is destructible, type, ptr type. We are calling destructor explicitly, ptr null ptr, or if ptr, then we can enclose like this. Now I will create a function. Now I will create a class cls type public. I create a default constructor std cout class type called std, and now I define destructor cls type std cout class type called std, and now we will test placement delete. We will test placement delete like this. Void advanced placement, new, delete. I will copy this function and I will disable it. Here, size t, element count, 10 elements, std, unique, ptr. Please note that we are using character buffer. New, we are allocating memory, element count times size of class type. We are dynamically allocating 10 instance of class type, CLS type. Okay, the syntax looks a little bit ugly. Why is squiggle? Sorry, it should be character. Okay, now here CLS type ptr1 new buffer get. We are providing the address here, CLS type. We allocated one CLS type ptr2 new. Now we can use this pointer like this, +1. The next address, CLS type. Here I will make private intm member, int member int, mmember member. Then I will define simple operator here, print std or stream operator std or stream os constant CLS type t os t member return os. Now here we can provide values. Now we can display std cout ptr1 std and ptr2. Now we can delete like this, placement delete ptr1, placement delete ptr2. After delete we can recycle. For example, ptr1 new buffer get CLS type. We can recycle. Then I will copy this once again. Then I will delete once again after use. Please note that this buffer memory is managed by unique PTR. Now with this, we build once again. A. Please note that two constructors called, then the values are displayed. At this point, we use constructor, so two constructors called, 0, value 0 is displayed at this line, 1, we initialized 1 and displayed here, we delete, so destructor is called, we delete, destructor is called. Now we recycle this memory once again, we allocate with 3, then we display the value, then we call placement delete once again. So it works properly. The point here is, that don't do delete ptr1 or delete ptr2. We as a C++ programmer need to understand low-level techniques. We also need to understand the C language. We also need to understand assembler. We also need to have some moderate knowledge of hardware too. Understanding C language and assembler language is very helpful, and actually we have to understand. But that does not mean we have to use assembler language or C language construct in C++ programming. When I decided to film about this video, I have been hesitating. Should I do this or not? But in this Intel Thread building block library, it is using low-level placement new. This is the address to place this new object. So I explained how to use placement new. In normal C++ programming, as C++ application developer, you actually should never need to use placement new or placement delete operator. I will post complete source code of this episode in my website extensiontalkplayfun.com. By clicking this link and show in folder, if you unzip this file, CPP extension tutorial folder, you can find the complete source code. I will post the source code of this episode to this website, CPP library extension to this website. Please subscribe to my YouTube channel. Thank you for watching.